All right, so let's talk about Java. Java is a high-level, object-oriented, strongly typed, compiled, general-purpose programming language. All right, so that describes the Java programming language in terms of our multiple, there are 3 kinds, there are 2 kinds of language. If you were at a store looking to buy Java as if Java was a product, what are the selling points that you know of for Java? Like, what's good about Java? Let's go back to the C++ days, C and C++ days. Let's say you were a video game fanatic on computers. And back then we had this war between Apple and Microsoft, right? Like, do I get a Mac? Or actually back then it was, do I get an Apple computer or do I get a IBM compatible computer? And for gamers, the answer was almost always get a PC, what we call today a PC. Why? Because when companies came out with video games, they wrote a game for a computer, for a PC, it would come out for the PC first. Why? More of them. So if we line 1,000 people up today, and we take a poll, how many of them run Windows versus how many of them run the Mac OS, what do you think the breakdown will be? It'll be closer today than it's ever been in history. I would say 900. Yep. So, and that's as close as it's ever been. You might have a couple of people in there who run both. So you just throw them in the Mac camp. Like, they're at least running Mac, so it's that's okay. So if you're writing software, writing a video game, you're going to write it for, I mean, you ultimately are doing it to make money, right? So you're going to write it to sell to the most people. The most people were running Windows on a PC. Now, if you were a Mac user, you could sit back and hope that the game eventually comes out for the Mac. But very, very, very rarely did games actually get ported to the Mac. Didn't have enough. There wasn't enough users to make it worth the money. It's just the way it is. We can take this a step farther, make an additional connection here. How many of you have heard the claim that Apple has no viruses? That if you run a Mac, you don't have any viruses. How many of you have heard that before? Didn't ask you if you believe it. How many of you heard it? Okay, how many of you believe it? You believe it. You believe it. Okay?
I'm not sure.
Now, we all know that Windows has viruses, right? Okay, who writes viruses? Programmers, right? Mean programmers. Okay, if you're a mean programmer and you're writing viruses, what's your goal? To piss people off. Okay? So if your goal is to piss people off, and you got 1,000 people sitting in front of you, are you going to aim for the 100 or are you going to aim for the 900?
900.
You're going to aim for the 900. No wonder there's so many Windows viruses. Now keep in mind, I'm a Mac guy. Okay? So I'm about as biased as you can get. But, I mean, there is no reason why there could not be viruses for the Mac. And there are a few. You could make an argument that the operating system that Macintosh runs today is actually based off of a Unix-based operating system, which is typically considered to be very secure. I think you could make the argument that it would be more difficult to write viruses for the Mac than it would be to write viruses for Windows. But not like drastically. Maybe 20% more difficult or something like that. The real reason there aren't that many viruses for the Mac is because there's not that many users on the Mac. All right, so Java is a high-level language. So the question I asked is, if you went into the store and you were looking at what the features of Java are, the big thing would be something that Java is what's called platform independent.
That's the word.
A platform independent. So the example I was going down there is like when somebody comes out with a video game for Windows, it takes time to bring it over to the Mac if they even choose to bring it over to the Mac because they have to rewrite part of that game. So platform dependent gets rid of, here, let's say, gets rid of porting code. And what does it mean to port code? If somebody were to write a game, more than likely the game was written in like C++. So if somebody wrote a game in C++ for Windows, and then they wanted to release that same game on the Mac, seems like not a big deal. We just have to find a C++ compiler for the Mac. Because remember, what's the job of a compiler? Compiler takes a high-level language and translates it into a low-level language that can then be interpreted by the processor. Well, Macs and PCs, until recently, use two different architectures. For years, Macs used PowerPC chips, which is a reduced instruction set processor, where PCs use Intel-based chips, which is a extended instruction set processor. So the assembly languages were different. Now the assembly languages are the same on both of them. So it seems like moving an application from one to the other should actually be less of a headache now, which is definitely true. But here's the deal. So when you compile a C++ program for one platform, you get assembly language code that gets eaten by the processor in that platform. When you compile it for the other platform, you get assembly language code that gets translated by the processor in that platform. Now, having said that, there's more to it than we've explained. That is, you have an operating system in the middle. Operating system is a piece of software that sits between the human being and the hardware. So when your game makes pretty pictures and stuff like that fly up on the screen, it's not just doing that directly. It's actually talking to your operating system, which talks to a software driver, which talks to your hardware, which makes pretty pictures show up on the screen. So you have to rewrite portions of your game to talk to drivers differently because they have to talk to the operating system differently. So you have to rewrite portions of the game even though you're using the same language because you're speaking to a different operating system. It used to be even worse. It used to be you were speaking to a different operating system, which was then speaking to a different hardware architecture. On top of that, most video games on PCs use DirectX. That's Microsoft's show pretty pictures libraries, okay, making explosions and a zillion polygons on the screen at the same time, where the rest of the world uses OpenGL. So anything Microsoft-based uses DirectX. Everybody else uses OpenGL. Yet, most games come out for Microsoft first. So they're written using DirectX because that's going to get you the best performance on a PC because it's so integrated into their operating system. And Microsoft invented it. So if you're to rewrite a game now for the Mac, you're going to have to not only port it to talk to a different operating system, you also need to port it to display graphics differently. Write everything in OpenGL rather than DirectX. So, I mean, it's a major undertaking. So that's where Java comes in. This was a huge problem back when Java was originally invented. Java was probably invented in 1994, 5? I want to say it's 1994. All right, we're going to look it up. Where's the date?
1995, yes.
Yes, first released in 95, but it was developed in 91.
All right,
Second paragraph.
got it. All right, so 95. That was close. That was close. Okay, so 1995. Fine. So back then, it was certainly a big problem, this whole idea of writing software for two different platforms. Because it wasn't just for video games. It was also for business applications. So if you needed Microsoft Word, or the equivalent thereof, for the Mac, and you were currently on the PC, it was a big headache. Because there weren't as many applications. That was the Macintosh killer for years. It wasn't that Apple was innately bad. It was the applications weren't there because Windows had a significantly larger market share. And that just kept growing and growing and growing. So Apple had its little niche, which was in the graphic video industry. Just so happened, so Apple has always been kind of had a cult following, right? You had a group of people who just loved everything Apple made, regardless of how good or bad it was. Apple, 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 Apple. And it just so happened that the important people in graphics and video industry were into that idea of Apple being awesome. So they pushed the envelope to get software developed for the Mac for those things first. So like Photoshop, a lot of different video editing software, those were born on the Mac, and that's where, so if you go into a design firm, you're going to see a lot of people with Macs, even 10 years ago. You go into any other place, you're going to see PCs running Windows. So in any case, this was a big deal because we were in a world at the time where the internet was just coming into its own. I mean, 1995, that's right around the time Al Gore invented that thing. Do you even know who Al Gore is?
Al Gore?
Al Gore.
Person?
No, never mind. He asked a question.
He can't answer a question with a question.
I don't know.
The joke is he was the vice president of the United States who ran for president, and while he was running for president, he had a comment where he said he invented the internet. So now it's referenced often. It's funny. So anyways, that's when he invented the internet, was like 94, 95, 96, somewhere in that ballpark. Probably more like 94 is when the internet started being used. So, used a lot. It existed before that. But in any case, this idea of downloading programs off the internet was starting to become a reality. So the people at Sun Microsystems decided, you know what? Wouldn't it be cool if you could write a program once, and that program you compile it once, and that program would run on every computer? Sounds like a good plan, right? The problem is solved. So what did they do? Prior to this, this is how stuff worked. I get to draw pictures. I like pictures. We'd have a game. Okay, so the game would come out originally for the PC. Okay, so it was built to run on the PC. Now, if we wanted that game to then work on the Mac, they would need to port that game, rewrite that game a second time for the Mac. Make sense? Time, money, blah, blah, blah. So Sun Microsystems decided, hey, let's do this. You got Mac and PC. Write the game once for both. Looks great on paper, right? This one is better than this one. When you're looking at it from this point of view, correct?
So this one represents Java.
This is Java over here. This side here. That's Java. Here, I'll put a little text. So that's Java. This is the other crap. All right?
Aw,
True.
whatever.
True. Don't worry, your Microsoft is going to come back here into the story in a little bit. They come back strong, trust me. It's going to be awesome and hilarious at the same time. Okay. So, this model looks awesome over here, right? So, how did they pull it off? Over here on the left, the other crap, they wrote the game once, then they wrote the game a second time. And if they wanted it to work on Linux, they'd write it a third time, so on and so forth. So what did they do to make Java work this way? Instead, now if there was, let's say we had 30 video games, and they wanted all 30 of those video games to work on both Mac and PC using the other crap, they'd have to write those programs 60 times, right? Okay. So instead, the people from Sun Microsystems, they decided, rather than porting every one of your applications, we're instead going to create our own little application called the Java Virtual Machine, the JVM. Now, the Java Virtual Machine is just like that game. If they wanted it to work on the PC and the Mac, they had to write it twice. They had to write the Java Virtual Machine for the PC. They had to write the Java Virtual Machine for the Mac. Make sense? But after they wrote those for those 2 or 3 different platforms, they were done. So this game was written in Java, and the game was not run by the PC or run by the Mac. The game was written to run on the JVM. So the way Java worked is you'd write your program once, and when you compiled it, it was not compiling it to assembly language code that could be understood by Intel. It was not being compiled to assembly language code that could be understood by PowerPC, by the Mac side, by the Windows side. Instead, it was being compiled down to assembly language code that could be understood by the Java Virtual Machine. The Java Virtual Machine is a computer written in software. So this guy here for the PC understands the exact same assembly language as this guy written for the Mac. What they do with that assembly language and then feed it onto the Mac might be different. It should be logically equivalent, but the virtual machine for the Mac and the virtual machine for the PC are 2 separate applications that are meant to be functionally equivalent, but the way they pull things off might not necessarily be the same. Over here, this guy had to write things in terms of the Mac operating system, in terms of the Mac hardware architecture. Over here, this guy had to write things in terms of the Windows operating system, in terms of the PC architecture. That makes sense? But Java always compiled its programs to run on a software CPU called the Java Virtual Machine. So you write your program once, you compile it once, it will run on any platform that supports the Java Virtual Machine. Sounds pretty legit, right? Okay. Isn't this perfect? No wonder Microsoft wanted to steal this. You write any Java program with any legal Java code. It does not matter what the platform is, as long as there's a virtual machine for it. As long as the Java Virtual Machine exists for the platform you intend your program to run on, it will work. And you only have to compile it once. You don't have to recompile it. I can go down there to, I can go right here, write a Java program, compile it. The output will be this thing called a .class file, which is Java bytecode, which is Java assembly code. The assembly code understood by the Java Virtual Machine. I can then take that one file, not even my source code, just the .class file, and I can go across the hall to what they call the fishbowl here, which is a bunch of Windows machines. And I can run my program in there without compiling it again. It'll just run. Because I compiled it down to a low-level language that the virtual machine knows how to eat. I'm feeding the same pet. I'm feeding a virtual machine here. I'm feeding a virtual machine over there. Internally, those virtual machines maybe are wired a little differently, but functionally they're equivalent and they eat the same food. Does that make sense? Okay, so on paper this sounds like a cool idea. No wonder Microsoft wanted to steal it. We have a problem. Goes back to our old problem we talked about before. Performance. Performance. Now, Java is great for business applications. Who cares? Our computers are so fast today. Are we going to notice the difference between how fast Microsoft Word is on one machine versus another? No. It's not a performance type application. As long as Word feels snappy to us, we don't care if something takes nanoseconds less than something else. We're not going to feel it. We do care about our video games though, right? If your video game is sluggish, you stop playing it. You just assume your computer can't handle it, right? where it very well could be that your computer is fine, but the dude who wrote your game or wrote it in Java. So Java should scream slow performance. Again, relatively speaking. So not slow from a human's perspective. Java's fast. If I wrote a program in Java on here and I ran it, it would run instantly. It wouldn't seem like there's any delay. But if you wrote a program that really, really relied on top tier performance, a video game or something like that, Java's not the platform for you. It's just not going to be able to handle it. So Microsoft, first of all, they like the Java language. Java language had two things going for it. Let's talk about that. Advantages of Java. Well, first of all, it had the platform independence. Clearly, we could say, even though it wasn't ideal for all situations, it was definitely cool for many situations. Right? Platform independence is good. Period, it's good. What else did it have going for it? Better than C++. So hold on. What does it mean for something to be better? It's a very relative term, right? C++ was how all of our video games were written, and they were fast. C++ was a compiled language that you had to port on either platform, whatever platform you wanted your game to work on. Super, super, super fast. But C++ had its shortcomings, especially from a teaching perspective. So historically, the first language computer science students would learn is either C or C++. Usually they would learn C first, because you always learn procedural programming before you learn object-oriented programming, even if you're using an object-oriented language. Like when we start in here, we're going to be approaching Java, which is an object-oriented language, from a procedural mindset. So we won't be taking advantage of the object-oriented aspects of it until 3 or 4 classes in. So we might as well be learning C at that point. Okay? But when you finally got into C++ or C, it had the same issues. For a beginning programmer, C, very robust language, very good language, but you could get into trouble quickly. C++ empowered the programmer to make poor decisions. Now, not the end of the world in the big scheme of things, because advanced programmers sometimes could take advantage of some of those elements to pull off, let's call it, unique solutions to problems. Certain problems could benefit from the doors that were left open by C++ that allowed you to do stupid stuff like that. But for a beginning programmer perspective, and you guys are going to see, for those of you who haven't done programming, or those of you who say you've done programming but actually suck at it, you're going to see that you're going to have a whole bunch of errors at the beginning. Okay, they're just going to come flying at you like crazy. When you're a beginning programmer, it's everything you can do to get a program working, let alone doing it the most efficient way. C++ lets you get away with murder when it came to efficiency. And it trained a lot of programmers to do the wrong stuff. But even worse than that, how many of you are familiar with the blue screen of death? Yeah. Anybody who runs Windows has seen the blue screen of death before. Anybody who runs iOS 7 on the new iPhone 5S has also seen the blue screen of death. This is the 5S. This is their new phone. And it's got a new architecture on it. So it's related to what we were talking about. The chip that's inside of this is a 64-bit processor. Holy man. The chip that's inside of previous iPhones was a 32-bit processor. So very related, actually, to what we're talking about here. In fact, I'm not even joking. It is actually related. So for the last year, Apple has been working on this new operating system, iOS 7, and has been testing it on 32-bit processors. So they'd write it, they'd compile it to that architecture. This is a brand new classification of processor that's in this guy, a new 64-bit chip. So they had to port iOS 7 for the new chip. Well, they probably decided to put the 64-bit chip in here a couple months ago, maybe like a month and a half before the phone was released, let's say. So A piece of software they've been working on for a year to get ready for the 32-bit processors. They only had like a month to port it over to make it work for the 64-bit processor. So my wife still has an iPhone 5 that has a 32-bit processor in it. She's running iOS 7, no problems. I have the new one, the 5S, coolest, biggest, baddest, blah, blah, whatever, and it's a nightmare. My phone reboots 10 times a day. There's like stupid little bugs, like things that don't even make sense. You know, so like I'll voice dictate something. And sometimes, especially here on campus where you have crappy Wi-Fi, it'll sit there and spin at the end and not actually translate it. Fine, that happens. So I might sit there and wait 10 seconds. Didn't happen. I hit the backspace button to tell it to stop trying. Then I maybe turn Wi-Fi off to use my cellular signal. Then I go and voice dictate it again. But maybe I reword it a little bit or make it short or whatever. When I hit stop, what does it do? It gives me my old message, the one I originally had set. 100% of the time on the 5S. 5 works fine. No problem. This morning, this is the fourth or fifth time this has happened. I had hit snooze on my alarm a couple different times, so I don't remember the exact order that things have to happen, but eventually I turned my alarm off on my phone, but the phone disagreed. The alarm must be on. So I uploaded a screenshot from my phone on Facebook this morning. If you're not friends with me on Facebook, you should become friends with me on Facebook. I write a lot of funny stuff on there. So I uploaded this photo that showed that my alarm was clearly off. Yet the alarm icon was still at the top. So one might ask, well, is it just for show? No, it will still go off again. But then it would be even more interesting this time around because I was in the process of snoozing as opposed to waking up before the alarm originally went off and trying to turn it off. So the real question is, was the alarm going to still go off based on my snooze timer, or was I already ready for tomorrow morning? It was a snooze timer is what we found out. It also survived a reboot. I started the phone back up. Yep, icon was still up there. So anyways, C++ lets you get away with a lot of things. And the reason I brought up the blue screen of death question is blue screens of death happen under lots of different circumstances. One of them is things with corrupt memory. Since C++ gave a programmer free reign of memory, that's great if you know what you're doing. But if you're a beginning programmer, you're just going to overwrite memory when you don't know you're overwriting memory. Java fixed a bunch of this stuff. What Java did is they went in and they said, we really, really like C++. There are a zillion people out there who already know C++. We don't want to alienate those people, so we want to keep that syntax. We want to keep the C++ syntax. If I were to show you this tree here, more pictures, like pictures. We have C. Off of C came C++. And Objective-C. See? Apple, Microsoft, they didn't even like each other back then. These guys are fighting with each other at hardware level. All right, so the parent there is C. Off of C came, we decided, hey, object-oriented programming is cool, so we need object-oriented languages. So Microsoft pushed for C++. Apple said, well, we're not going to do what Microsoft's doing, so we're going to do Objective-C. From C++, came Java. And later C#. Notice I shifted it down just a little bit off Java. And for Objective-C, wait for it, Objective-C 2.0. Objective-C 2.0. So this is kind of our hierarchical tree for these guys. So back to advantages of Java. was better than C++. We took all this crap that was in C++ that wasn't bad for an advanced programmer, but was a problem for a beginning programmer. And even advanced programmers would benefit from not accidentally doing something that makes no sense. I mean, C++, you didn't just have to be dumb in order to accidentally hand somebody the house. A little tiny syntax change, and you were handing them the house rather than handing them the address to the house. The only difference was an asterisk. So, a very easy mistake for even an advanced programmer to make. Java fixed all that by just saying, look, you're always handing them an address. Deal. That's what Java did. In fact, something I'll say again, but I'll say it right now. If you look at a lot of the different Java textbooks, almost all of them, which is why I don't use a textbook, they're all liars. Almost all of them mention that pointers don't exist in Java. We're going to talk about pointers. Pointers are a primitive type variable for holding memory addresses. They say they don't exist in Java. The reality is Java only supports pointers, so it doesn't have a special syntax for it. It's more accurate to say pointers only exist in Java, yet the books say they don't exist in Java, which is just stupid. That'll make sense when I show you some examples, but another stupid thing is why we don't have a textbook. So you can make your donation after class. All right, so other advantages of Java. I think those are the two main ones. All right, so enter C#. This is from Microsoft. Now let's look at how this guy works. Done. It's the same diagram I used for Java. I just changed all the JVMs to .NET.
That's exactly what the Microsoft did. Copied Java.
So first they just stole the syntax straight up. And then they say, you know what? If you're not going to let us have the syntax, we're at least going to still be platform independent. So C# was what? C# was C++-like syntax / Java like syntax. So they were both based off of that same tree structure. So back to, where was I out here? Where's my picture? Oh, here it is. So notice Java, C#, they're both derivatives of C++, which is a derivative of C. So a lot of the syntax is the same anyways. All right. So that was an advantage of C#. C# was platform independent. Which is great, right? But, now let me show you where they differed. Go back to this diagram. We already know how the other crap worked, right? So we can get rid of that. So let's look at C# in a little bit more detail. So in C#, we'd write a program. We would then compile that program down to Microsoft Intermediate Language, missile code. Okay, so this movement was a compile move. To go from those two steps required compilation. Then we send it into .NET. But .NET used a series of just-in-time compilers. So it's actually compiled twice. Hold on, I've actually made a mistake here. This is low-level language, assembly language. Then we had our missile code. So we compiled our program down to a low-level language. Then we fed it into a just-in-time compiler. I actually got to move the .NET over too. We fed it into a just-in-time compiler, which converted it into Microsoft Intermediate Language. And then we fed it into .NET, which is like the Java virtual machine, and that ran the app. Okay? The important difference here is after that second compilation, we're dealing with native code. So only the first time that you ran the program would there be that extra time of compiling a second time. After that, you'd have a native program that ran natively on that computer, as if it was compiled directly for the processor. So it worked very similar to how Java worked. But instead of writing your game once, compiling it to Java bytecode, and then running it on the Java virtual machine each time you wanted to run it, Java virtual machine kind of being like an interpreter, like me talking to him through you. Instead of it working that way, for .NET, for C#, the way it worked is I wrote down my English. You translated it into something else. Okay. But only once. He's the computer. You give it to him, and now whenever he wants to run that program, he already has a translated version of it. Instead of, with Java, it would be, I write it down, give it to you, you compile it, then you speak it to him, and then the next time we run that program, we do the exact same thing again. So I always use the interpreter every single time I run that program with Java. With .NET, I only use the interpreter the very first time, where you take all my code and you turn it into something he can understand forever. Does that make sense? So at that point, we get all of our performance back because now all the code that you run is native. So only the very first time we run that program is there a little bit of a delay for us to do that translation between English and Arabic, between a low-level language, some kind of assembly language, and Microsoft Intermediate Language. Make sense?
And that's only on different platforms.
Well, again, remember that C# is, of course, platform independent.
Right.
And that's how it works. So which is better? C# sounds better, right?
Mm-hmm.
Oh, so you fell for my trap. Fell into a trap. Watch this. So C# is platform independent on any platform that supports the .NET component architecture.
That would be a catch.
So to reword this, C#, you could write your programs and they are platform independent as long as your platform is Windows. Because Microsoft did not create the .NET component architecture, the .NET stack for Mac. It's only for PC. It's only for Windows. So is C# platform independent? Absolutely. The whole .NET architect, the whole .NET language suite is platform independent as long as you're running Windows. Could Microsoft port it over to Mac? Sure. Why don't they? There's no benefit in it for them. Right now, if people write C# programs, they have to use Windows. First of all, they're writing software for Windows, right? So they're supporting Microsoft's platform. And they're also Windows users themselves. The second you allow people to start writing software using your product for somebody else's platform, you give up market share, don't you? And where's Microsoft's motivation? They have 94% of the market. Well, that's probably being conservative. I mean, they have a huge, huge percent of the market. They have no motivation to go and give that extra little 3 or 4% guy a bone. So it doesn't make any sense. So that's the funny thing with C# is C# is platform independent as long as you're running Windows. As long as you're running a platform that supports the .NET component architecture. So we go back to the Java side of things here. Sun Microsystems wrote the Java virtual machine for the PC. They wrote the Java virtual machine for the Mac. They wrote the Java virtual machine for Linux, so on and so forth. Microsoft did the same exact thing. They just chose to only write the .NET component architecture, only write the Microsoft virtual machine for Windows. Does that make sense? They stopped short of what Sun Microsystems did. So C# is actually a pretty cool thing in that it has all of the benefits of Java on the surface. Certainly it has the language benefits. Certainly it has the better than C++ thing where you know, in C# you cannot pass a house. You can only pass an address. So it has all those advantages from a programming perspective. It has the platform independence concept without giving up the performance, which is cool in and of itself. In fact, Java actually learned from this. So Java software today is actually a little quicker than it used to be because what they did is they inserted some just-in-time compilers in here to speed up certain aspects of a program. I mean, you're not getting native code. You're not to that point, but certain aspects are quicker. All right, so that's the difference between C# and Java. IDE, this is an integrated development environment. What is it really? A glorified text editor for writing programs. That's what it is. To give you a quick example here.
You said for writing?
For writing programs. The tool we're going to use in here is a tool called Eclipse. You use Visual Studio for writing your Visual Basic stuff. Eclipse is Visual Studio for Java.
Gotcha.
Okay?
I have to use it anyways for AI.
So you're going to be using Eclipse in here. And just to kind of give you an example of how this guy works. What you'll be doing for your first program, for your homework.
Hello world.
What's up?
Gonna be hello world.
Yeah, but learning to use Eclipse is the thing. You'll create a brand new project, and there's a tutorial that you'll go through to do this, and then you'll write a tutorial to do this too. It's gonna be awesome. So anyways, ultimately, this is a text editor. This looks just like Notepad, right? Mm-hmm. But it does some stuff that makes your life a little easier. For instance, if I'm writing the main method, public static void main string array args, and then I put my opening curly brace, it puts the closing curly brace on there. You know, things that make programming life a little easier. Glorified text editor. All right, same thing. I go and write my code to print something out. And then come up here, hit the play button. Hello world. Now, what's the alternative? Well, take a look. The old way. So let me do this on my desktop first. So I'm going to do vi blah.java. All right, so there's my Java program. But I wrote it out in a text editor called VI. I did the indenting myself to make it look pretty. I had to close all the curly braces. Now I'll write it. Now I don't have a play button. First of all, I got to compile it. So I'm going to call my Java compiler, javec, blah.java. And you'll see it now created a brand new file here called blah.class. That's my Java bytecode. Now to run my program, Java blah, and there's my hello world. That's what the play button did for me. I hit the play button, it compiled it, it ran it. I didn't have to do all that typing and crap like that. But appreciate the fact that you don't have to do all the typing and crap like that. Okay, because this was the way that used to work.
So where do we find Eclipse?
I'm going to show you.
Gotcha.
All right. So, and I'll put this up on Angel as kind of a formal assignment. You'll read it, but what you're going to do is you're going to go to a website, www.eclipse.org. Okay, it's going to take you to a page like this. You're going to click on Downloads. And it's going to detect what kind of computer you're on, whether you're on a Mac or a PC or a Linux machine. Okay? One of the reasons we tend to use Java as a teaching language rather than C# is for C#, you have to be on Windows to use the compiler. That's a 97% truth. There's actually a tool called Mono that lets you do it cross-platform, but it's not equivalent. You have to be on Windows for C#. This one, notice it already detected I'm on Mac OS. For you, it'll detect you're on Windows or on Linux or whatever you're using. The one you want is Eclipse IDE for Java developers. All the other ones will have extra crap in it that you don't need. Okay? Doesn't matter if you get the 32 or 64-bit one. They'll both work fine for you. So download that. Install it. There's actually no real installation on Mac or Windows. There is it just gives you a folder with an icon to double click on. Okay, but for Windows, you will have to install the Java virtual machine. Java virtual machine, you'll get from java.sun.com. You'll over here under new downloads, Java SE7 update 45. At some point, they just need to call it Java SE8. It seems like. So click on that. Go through the process of downloading the Java SDK, not the JRE, the SDK. JRE is the Java runtime environment. The SDK is the software development kit. Software development kit lets you compile and run. Okay, more than likely you will have to download that for a PC. Okay, you very likely already have a Java runtime environment on your PC if you have the little Java logo somewhere on there for running Java apps inside of web pages, but likely you do not have the SDK. Macs come with the SDK. So if you have a Mac, you won't have to do this part, but a PC, you will have to download the SDK and tell Eclipse to look at it.
So,
For what? Windows? Yeah, Windows you would get the Java development kit. This guy.
okay.
Mac you won't have to, because the Macintosh already has it.
We get the Java
Java development kit.
And then which ones out of the SDKs for Windows?
Well, hold
You
on.
were just pointing to the side.
Oh, I was just moving the mouse around.
Oh, okay.
Yeah. You want the Java development kit.
Gotcha.
This guy. Once you have that and you have Eclipse, you'll tell Eclipse where your Java development kit was downloaded, and then it'll work.
Okay.
Okay? And I'll point you to a couple of tutorials for getting started with Eclipse on the Eclipse website that tell you if you're on a Mac, do this. If you're on a PC, do this. Okay? But ultimately, what we're going to be using in here is an integrated development environment, and that integrated development environment is going to let us write our programs and test them easily. All right? So, go ahead.
Oh, I'll ask you afterwards.
Your assignment will be 2 parts, actually 2.5 parts in this case. I will be having you go through the process of getting Eclipse downloaded and installed and writing a hello world program, like kind of your simple first program. On one hand, that proves to me that you have a development environment you can code in. I will also then have you write a tutorial for teaching other people how to get it up and running, okay? Because we are IT majors. So part of what we're going to be doing is we're going to be instructing other people how to use technology. So you need to be able to take what you learned how to do and explain it to people who might be less technical than you are. Okay? Then there'll be a paper component that will be related but unrelated to that.